4.3, number 128. Find the local and or absolute maxima in particular. It doesn't say extrema, it just says maxima. A little odd. For the function, which in our case is f of theta is 4 sine theta minus 3 cos theta over the interval, closed interval, to 0 to 2 pi. Okay, so it's closed interval, so therefore it has to have an absolute maxima as long as this function is continuous, which it is because it's a difference of two continuous functions. So therefore it is continuous over 0 to 2 pi, closed interval, and therefore according to the extreme value theorem, there must be an absolute max and absolute min, although they're not asking for it. But the problem here is the word local. The book is talking about determining local extrema when they have not yet shown how. This is a flaw in the textbook to some degree. So what I'm assuming is happening here is when we find the critical values in a moment, it must be that the book has structured these problems, these functions, to automatically have relative extrema at these critical values, it would seem. That's not the case in general, as I tried to show in the counterexamples in the introduction. And so their wording is a bit presumptuous here, but I'm going to assume for now that as long as I find a critical value, it must be also the location of a local max or min, even though in real life, in general, it doesn't have to be that way. All right, either way, we need to take the derivative and set equal to 0 and find out where it's undefined. So f prime of theta should be, the derivative of 4 sine is of course 4 cos. The derivative of 3 cos is of course negative 3 sine. So coupled with this negative should give us a positive 3 sine theta. I would like to know where this is equal to 0. I would also like to know where it's undefined. We said that's also the idea of a critical value, is where the derivative is undefined. But in this case, there's nowhere this is undefined because these are cos and sine functions added together. So I only have to worry about, practically speaking for this problem, equal to 0, even though in theory I should also be concerned about where it's undefined. I don't have to worry about it for this one. All right, this is not a simple equation to solve. As a matter of fact, what I'm going to do is this. I'm going to move the 4 cos theta to the other side, perhaps. So I have 3 sine theta equals negative 4 cos theta. I'm going to take some special care with this particular problem. There's no wonderful trig identity which is going to get this in the state where I have just sine functions or just cos functions. Nothing too wonderful there. So I'm just going to do this instead. I'm going to structure this as a tan function. I'm going to divide off by cos. I'm going to divide off by 3. So I'll end up with tan theta equals negative 4/3. Okay. Now really normally I would try to solve for theta, right? Solve for the independent variable. But I'm not going to do that. I'm not going to do that here. Okay? There's another way to go about this. This theta is special in the sense that it causes tan to become negative 4/3. Even if I don't get the exact value of this variable here, I should still be able to say something about the problem. Now, I'm only worried about this theta being between 0 and 2 pi. So if I draw a picture here, I'm very fond of drawing pictures when dealing with trig functions. I think it helps immensely, and everybody should try that anytime they're stuck on something with trig functions. Start drawing some pictures. It is usually of some help. So think about the unit circle, then tan theta is negative in second and fourth quadrants. And if tan theta is negative 4/3, that means if I just draw something, it has to be very accurate, but just something here. That means whatever this value, whatever this angle is in here, it must be that this is negative 4 and this is 3, right? Opposite or adjacent. And I have to associate the negative with the opposite in this picture down here because it is clearly a negative y value and the x is clearly a positive x value. So the negative gets associated with the 4 when I'm in the fourth quadrant. When I'm in the second quadrant, drawing a similar type of picture, which does not have to be very accurate, right? Whatever this reference angle is here, it must be that I would have a positive 4 here on the opposite side, that's the numerator, but the negative will now be associated with the denominator because clearly over here x is negative. Right? There's our adjacent side. All right, this is a 3, 4, 5 Pythagorean triple. Right? You can check that for yourself. Just square plus square and then take square root. You'll get a 5 for the hypotenuse. It's not a big deal. All right. Here's our right angles. Okay, so what I know is tan theta is negative 4/3, and so whatever angle theta is, right? It's either this number here, right? It's that one, or it's all the way around here, that one. It's not the actual reference angles in here. That angle between 0 and 2 pi, which there are 2 of them, right? I have one here, and I have one here. Sorry, I went too far. One here, say like that, there, before I get to the reference angle. Same thing here, I went too far, I wasn't thinking. Right, before I get to the reference angle, so that angle and then this one, those 2 angles cause tan to be negative 4/3, and therefore I can also say something about their cos value and their sine value back in the original function when I need to. All right. So when dealing with absolute extrema, this one's specifically a maximum, I'm always going to use the endpoints along with the critical values.